In this lesson, we are going to write equations of hyperbolas given various information. So we are going to start by just reviewing the different equations of the hyperbolas, the similarities and the differences. No matter what, the center is always going to be the opposite of the h value and the opposite of the k value. So that's true for either a vertical hyperbola or for a horizontal hyperbola. And the main difference between these two equations is that your x squared and your y squared terms reverse places depending on whether it's horizontal or vertical. Remember, a squared is always going to be first for a hyperbola, and then if you have your y squared first and positive, then it will definitely be vertical. And if your x squared is first and positive. And the reason I'm saying first and positive is because in our equations for hyperbolas, we do have subtraction of the two terms. So that's why I'm saying look for the positive, either x squared or y squared. Put that first in the equation, and then that tells you the direction that your graph will go. All right, so some of the things that we could be told, we could just be given a graph, and that's actually kind of nice. The only thing you have to double check with the graph is maybe looking for the covertices. They're not always plotted, and sometimes that little rectangular box that we draw around to help us sketch our graph. Sometimes that's a little bit tough to see, so be careful with that. You could be given the center, the foci, the vertices, covertices, slope of the asymptotes, and the lengths of either axes, and any combination of those. You could just be given vertices and foci, and that will be enough in order for you to determine out which axis states your direction. So your transverse is going to tell you the direction that your graph is open. And it's similar to the major axis where its entire length is 2 times a. And it will include the vertices, it will include the foci, and it will also include the center. And then just a couple other things. From vertice to vertice is your distance of 2a, but just your a value is the center to one vertex. And just your c value is the center to one of the focus points or one of the foci. So just remember that from foci to foci, those always give you a length of 2c. Your conjugate axis is kind of like your minor axis. It has a length of 2 times b, which directly relates to your covertices. And the only other thing that will be on your minor axis will be your center as well. So remember, if 2b is the length of the vertices or that entire conjugate axis, then just your b value goes from the center to one covertex. Okay, so we are first going to look for the a squared in the denominator, hopefully. Then you can in turn look at the variable in your numerator. A squared, remember, always has to be first. So, excuse a little teeny tiny bitty space right there. If a squared is under your x squared, again, this has to be horizontal. And if your a squared is under your y squared, which should be first and should be positive in that case, then it will be a vertical hyperbola. Okay, and we've said that several times, so that's probably pretty darn important for writing these equations and doing your graphs. Our first example, we are just going to review a couple of things that we've done in the last lesson. We are going to state our center. So this one is x minus 3 quantity squared over 9 minus y plus 1 quantity squared over 36 equals 1. So we're going to take the opposite of our h value, which is 3, and the opposite of our k value, which will be -1, and that would be my center. In this case, because the x squared is first and positive, my a squared will be first as well and underneath. So this example is definitely going to be horizontal. And if a squared equals 9, when I take the square root, we'll get that my a value equals 3. There in turn, our b value is going to come from what's underneath the second term, the y squared term, for this example. So if b squared equals 36, when you take your square root of b squared, you would get 6 for the length of b. So the slope of my asymptotes, if you need to just draw a rough sketch and kind of see what's happening to help yourself, by all means do so. So I have a point 3, -1 for my center, and I'm going to go to the right 3 and to the left 3, and those will be my 2 vertice points. Okay, if I go up and down 6, so 1, 2, 3, 4, 5, 6, there is a covertice, and way down here is another covertice. So if we were to sketch our little box that helps us do our graph and connect our covertices and vertices with a box going all around my center, you can determine your rise always over your run. So my rise in this case from the center up to the covertice, that is my b value, which is 6. And then over to this next corner, which would match the same x value as a vertex, I traveled to the left or to the right 3, which is my a value. So the slope of my asymptotes in this case is positive and negative. Remember, our asymptotes are going to go diagonal in both directions through those corner points. So our slope is up 6 over 3, so rise over run, positive and negative 6 over 3, which you can just simplify to positive and negative 2. That answer is perfect. So our next little part is to determine our foci. So I'm going to go ahead and sketch my graph out here. I'm going to go from the vertex out and approach my asymptotes. I do know that it is, again, horizontal. And there we go. So in this case, we should know that our foci is going to happen on the outside of where our hyperbola is graphed. So our c value for our foci, c squared, is a squared plus b squared, and that's because we have to travel past a vertex to actually plot a foci. So c squared is going to be 9 plus 36, which is 45. And when we take the square root of 45, we'll get both positive and negative 3 square root 5 when you simplify. So your note to yourself, do I add this c value to the x coordinate or the y coordinate of the center? So think about the direction your graph is traveling. We have a horizontal parabola, so I need to go from the center out to the right and to the left, so we're going to add to the x coordinate of the center. And what we've done in these cases is, because it's not a perfect square and I don't get an exact value, I would have to actually type in the calculator and get the decimal value of it. What we're going to do is we're just going to add that to our center. So I'm going to take my center, 3 for the x coordinate, and I'm going to add and subtract the c value of 3 square root 5, comma, and then keep my y value the same. Okay. So again, that distance would be 3 plus and minus 3 root 5, so somewhere over here where I've written my word vertice, and a little bit farther on the other side to the left, somewhere over here. And that's just a rough sketch so that we can kind of get an idea of what their graph looks like and kind of review all these different pieces. So a couple of other things that we can add just to help ourselves. If a squared is 9 and a is 3, then that means 2 times a would be 6, and remember, that is my transverse axis. You can also list those specific points for your vertices. You can 100% put those in there because you could be given that information as well. So I could say that this particular vertex was at the point 6, -1, and the other one was actually, I can't even write over there, 0, -1. And our co-vertices, they went up and down 6 units from the center. So this co-vertice at the top will be at the point 3, comma 5, because that's up 6 from the -1. And this guy down here at the bottom, that would be a co-vertex of 3, -7. Okay, and that corresponds with our B value. So we traveled down 6 units, so the entire length of our conjugate axis, 2 times B, would be 12. So that's all the different information that you can be given in order to write an equation. Okay, what can we be given? Definitely the center. That would make life easy. I would love to know the direction that the graph is going to open, and either the vertices or the co-vertices, and even the foci. Another thing you could be given is the length of either axis, so the length of the transverse or the conjugate. And you could be given, last but not least, the slope of the asymptotes, because that will also give you your rise over your run, which is either B over A or A over B, depending on which direction your graph is opening. When they give you the length, or if they give you the end points, that's another thing that they like to say. Remember, endpoints, those are just vertices and co-vertices, but when they give you the length of your axes, that'll be your 2A and your 2B values. All right, so our first example, this one's actually got a lot of stuff plotted on here, so hopefully it'll be pretty easy for us. So I definitely do see the center. That is clearly labeled, and that is at the point 5, -3. Okay, and then looking at our graph that we have, you'll notice that I have the the hyperbola drawn up at the top, and I also have the other portion of it drawn down at the bottom. So given a graph, that's nice. It's easy to determine that we have a vertical hyperbola. So what I like you guys to do at this point is make yourself a skeleton of the equation. You know the center, you know the direction that it goes, so you can already kind of start to fill a few things in. Since it's vertical, the y has to be first, so it's going to be y minus k squared over a squared. A squared's always got to be first as well, minus x minus h squared over b squared. And I'm just putting the little b squareds there, and that will all equal 1. Again, we have our center, so our h is 5 and our k is -3. So this will be y minus -3 or y plus 3 quantity squared minus x minus 5 quantity squared. So now all we have to do is determine our a and our b values, and we can use our graph to do that. Remember, from the center to a vertex is an a value. So I can count from the center up to where the vertex is. That will give me an a value of, let's see, we're going from 5, -3 to 5, 1. So we're going from 5, -3 to 5, 1. So that is a distance. The distance that changes is the y values. That means that my a value is +4. So if a is 4, I can go ahead and square that and put that in the denominator underneath the y. Now we're going to do the same, but we'll do that for our b value. So in this case, I know I can count over because they've given me the box from the center either to the left or to the right, so I can plot that point. That would be a covertice, or the other side, there's the other covertex over here. The other thing you could do is you could continue on with the slope of your asymptotes. So I went up to the vertex, and I can travel the distance to the right to that point of my box that I would draw, and that will give me my b value, which goes from the point 5, or excuse me, whoopsies. it goes from the value of 5 over to 9, or 8, 5 over to 8. So that's a total distance of 3 units. So remember, our center to a co-vertice is B, which in this case is 3. And then I can square that and put it in the correct portion of my equation underneath my x. So our final equation is y plus 3 squared over 16 minus x minus 5 quantity squared over 9, all equals 1. This next example is actually different from what is in your original set of notes. I changed it because the original graph was just atrocious. So what we're going to do is go through and label some points. We have the blue curves as our hyperbola, and we have those gray lines drawn as the asymptotes. So if I find exactly where the asymptotes intersect, that will give me my center. So my center is at the point 1, 2. And I can look at the direction that my graph is drawn from the blue curves. It is definitely going to be horizontal. It is moving to the left and to the right. Again, go ahead and do that skeleton equation. You know the center and you know the direction it's opening. So it'll be x minus my h squared over a squared minus y minus my k squared over b squared, and it all will equal 1. So now we just have a few things to fill in and we're good to go. So my h from the center is 1, k is 2, so our equation is x minus 1 quantity squared and y minus 2 quantity squared. That's good. So it's easier in this case to count our a value over because we can determine where the two vertices are. So I have a vertex at 4, 2 and at negative 2, 2. So if I count that distance on either side, that a value has a distance of 3. Remember, we're going from our center to a vertex just to get our a. What you can do now is you can find the points that would create your box so that you can determine what your b value is going to be, where your asymptotes are. So find those corners, whoops, and then sketch your little box around those corners, and we can count our distance up and down to determine our b value. So from the center up to the top, that goes from 2 to 4. That distance right here, b would equal 2. It's the same distance going the other way from 2 down to 0. So if our b value is 2, then that means b squared would be 4. So our equation is x minus 1 quantity squared over 9 plus, or excuse me, minus, forgive me, minus y minus 2 quantity squared over 4, all equals 1. Okay, our next example, write the equation of a horizontal hyperbola. That's nice, they told me the direction right from the get-go. Centered at negative 2, 5, that's even better. And then they told me the slope of the asymptotes, positive and negative 3 halves. You can do a rough sketch if you want to. It might help you. I'm going to go ahead and fill in the information I know. It is horizontal, so the x squared has to be first. So it'll be x minus h squared over my a squared minus y minus k quantity squared all over my b squared equals 1. I know the center to be the point negative 2, positive 5, so I'll do x minus negative 2 to give me x plus 2 squared, and then just y minus that 5 quantity squared. Okay, so from our center, I'm just going to do a rough sketch of the center. I'm going to go the point negative 2, 5, there's my center, and the slope of my asymptotes, remember, it's always the rise over the run, so the y over the x. So it says to travel up and down 3, 1, 2, 3, so I'm going to go up 3, and then to the right 2, 1, 2. There we go. So I went up 3 over 2. That means my b value is 3 and my a value is 2 because the change in the x distance is always going to go with your x's, and the change in your y distance will go with your y's. So b is going to be 3 squared, which is 9, and my a value of 2 is going to be 2 squared, which is 4. So our equation is x plus 2 quantity squared minus y minus 5 quantity squared over 9, all equals 1. In this last example, we are given a few of the characteristics of the hyperbola, and then we're going to write the equation. This one gives us the center, a covertex, and a vertex. So I'm just going to do a teeny tiny little quick rough sketch of those particular points so that I can hopefully determine the direction the graph is going and then find some other information from that point on. So I currently have the center plotted at 2, 3, and the covertex plotted at 5, 3, and one of the vertices at the point 2, 7. So from here, I know my H and my K values, that's given. I can determine the A value from the center up to the vertex. That's going to be my A value. So from 2, 3 to 2, 7 has a distance of 4. I can also find my B value from 2, 3 to 5, 3. That is a distance of 3, and that gives me the half of the length of the conjugate axis. And I also know, based upon the way that I've graphed things, that this is going to be a vertical hyperbola. And that is because the vertex is plotted above the center. So in turn, the other one would be plotted below the center. So I would have just my hyperbolas going in those directions. So that tells me I need to start with y minus my h quantity squared over a squared minus my y minus k quantity squared over a squared minus x minus h quantity squared over b squared in this case will all equal 1. So I can substitute in my center of 2, 3, so it'll be y minus 3 quantity squared and x minus 2 quantity squared. My a value was 4, so a squared will be 16, and my b value is 3, so my b squared will be 9. So our final is y minus 3 quantity squared over 16 minus x minus 2 quantity squared over 9, all equals 1. That is our final example of writing equations of hyperbolas. Make sure that you practice some of these on worksheet H.